Hello people, welcome back. A small update from the previous video I made. I added like rotating boxes in addition to the boxes basically go up and down, left and right, etc. So what I was telling you guys about last time around is how I use the scene graph to keep track of like the rotations of objects and translation of objects relative to the object space of the thing itself. So as we can see here, like this box is rotating, and if the player would jump on top of the box, we basically make the player a child of the node representing this rotating box, and we should expect the player to rotate with the box since it's now a child of the box. So we can demonstrate this by basically jumping on top of this box, and as we can see, the player is now rotating with the box, and as the box rotates, the player rotates with it. And if we were to, say, jump off the box, then we are back on solid ground and the terrain doesn't move or rotate or anything, so we're stable. Now, in order to do this, we perform the same calculations we do when we jump off like one of these boxes here, basically up and down, left and right, etc. Only difference being is that the box also rotates, which these ones, I just want to come up for a bit, 3, 2, 1, go. So these boxes don't rotate, they just go up and down, so we don't have the same problems. Also note that now if I jump off of any box, I calculate the point where two boxes intersect and use that point to determine the height of the player. So the player now, when it jumps off a box, he aligns itself correctly, just touching the surface. So I don't get any stuttering effects, which you might have seen in the last video, which is quite nice. But anyways, back to the rotating boxes. So one of the challenges with the rotating boxes is, because the box is rotated, and if we make the player a child of the rotating box, it means the child itself will rotate with the box, and the rotation already applied to the box when you jump on it will also be applied to the player. So what we must do when we jump off the box is to record the current rotation of the box, and we then need to update the location, the local location of the player relative to the box with that rotation. We basically need to invert rotation, and then we decide what the location of the player is relative to the rotating box. That's one thing. So it might be if I jump now, say like on top of this corner in front of us, it might actually be that the player will locally be on the opposite side of the box, but because we apply the rotation which applies to the box to the player as well, it might be that the player actually ends up in a location where I actually jump in the box in the first place. So that's one. Second thing is, if you jump in the box, the rotation applied to the box also applies to the player. So it also means that the camera angle will suddenly change if we don't do anything about it, because say the box is rotated 90 degrees when you jump on top of it, and the camera itself also rotates 90 degrees. So to counter this, we basically need to invert that rotation and apply it to the camera whenever we whenever we update the camera angle. So that's what's happening here, which means we don't see some like drops when you jump on or off the box because of this. So if you see, there's like a whole list of numbers which help me debug this application. So the one to pay attention to is the bias, which is somewhere halfway through the list. So the bias is the rotation which I add to the camera, and we only need to consider that with jaw at the moment, since the box only goes rotates around the y-axis. So the bias is the rotation I add to the camera in order to preserve the rotation of the camera for the player. So otherwise, it get very disorientated if we jump off the box and the camera angle changes rapidly based on like the current rotation of the box. So to demonstrate this, so the bias now is like 96. So if we were, say, to jump on top of like another rotating box, say this one, you'd see that the bias now is almost like 200. Sorry, no, yeah, it's almost 200. And if we jump off the box, we become something like very different, so almost like, well, 298. So by keeping track of the bias, it means I can actually preserve the orientation of the camera for the player, which makes it easy for player to navigate, and there will be some changes. So that's all I want to do for now, concerning like collision detection and scene graphs, rotation, all that kind of stuff. So next thing I'm going to do is basically use all this stuff I got here to build like a small platformer. And I'll basically, well, probably just be like one level or something, just something to mess about with. If that's done, I'll give you guys the, basically give you guys executables to basically mess about and play with if you want. And that will be basically a precursor to like my actual game, which is basically create a horror game, but I basically take it, one step at a time. So that's it for now. Thanks for watching, and hope to see you guys next time. Hope you enjoyed the video.